Hello, in this video I'm going to be going over electron configuration, and we're going to be focusing on noble gas shorthand notation, also known as the abbreviated version. Alright, so zooming up on this guy, we have bromine, and we have a periodic table up there. Just flipped it up. And normally, according to the Aufbau principle, what we have to do is we have to start with the bottom and build up. So we start with hydrogen, doing the 1s1, 1s2, 2s2, 2p6, and so on. But that can get very mundane and tiresome. So what chemists have developed is an abbreviated version. That's using noble gases as our starting point instead of hydrogen. So we have bromine, which is right over here, number 35. And what we can do, instead of starting at hydrogen, we can start at one of these noble gases, but we need to start at the one that comes right before bromine. So bromine is 35, krypton is 36, argon is 18. The one that comes before 35 is 18, argon. So I'm going to write argon in brackets, and that's my starting point. So I'm going to continue right on to 19, which is in the fourth row, S section. So it's going to be 4s1, 2. It's filled up, same rules apply. We're now still in the fourth row in a D section, but you got to remember D is one less than the row it's in. So instead of 4D, it's going to be called 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we continue on in the P section now, 4P, 1, 2, 3, 4, 5, and we've arrived at bromine. Our noble gas notation is argon, 4s2, 3d10, 4p5. Alright, let's do another example. Why not titanium? Titanium is right over here, number 22. And we want to do noble gas notation. So we're going to start as noble gas that comes before 22, which again is argon. We're going to continue on for fourth row, S section, 4s1, 2. And then we're in a D section, so it's one less than the row it's in. Instead of 4D, it's 3D, 3D, 1, 2. Alright, cadmium. This guy over here, number 45. Noble gas that comes before that, it's 36, krypton. And we continue on. This is now the fifth row, so we call it 5s2. And here, this is the fifth row, but D is one less than the row it's in, so it's 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is cadmium. Alright, then we have fluorine. Fluorine right here, noble gases. Helium comes right before it. And it's helium, second row, 2s2. 2p, 1, 2, 3, 4, 5. 2p5. Alright, next we want to do barium. Barium's way down here. And this is actually no, it's not quite the hardest one. It's still a medium level one. So it's in the sixth row. So we got to go to the noble gas in the fifth row right here, 54 xenon. Put it in brackets. We're at 6s1, 2. That's it. That's barium. And the last one, nickel, right up here, 25. Actually, no, it's 28. Argon comes right before it. Continue on, fourth row, 4s1, 2. And then D is one less than the row it's in, so it's 3D, 1, 2, 3, 4, 5, 6, 7, 8. Alright, and that is noble gas notation, but I wanted to add one last thing, and that's counting the valence electrons. So again, valence electrons are those furthest out electrons, outermost electrons, electrons involved in bonding for chemical reactions. So here we got 4s, 3d, 4p. Looks like 4 is the outer energy. So 5 plus 2 is 7 valence electrons. Here we got titanium, 4s2, 3d2. 4 is the outermost energy level, so that 4s2, 2 valence electrons. So we have Here, 5 and 4. 5 is the outer one, has 2 valence electrons. Fluorine, outer one looks like it's 2. 5 plus 2 is 7. 7 valence electrons. Xenon, 6. Looks like that's the only one in this null gas notation, and there's 2 of them, so 2 valence electrons. And then nickel has 4s2, 3d10. 4 is the outer energy level. It has 2 electrons in it, 2 valence electrons. Alright, that's noble gas notation. And then counting valence electrons.